Hey everyone. In this video, we're going to be talking about how to name alkenes and alkynes. So in the previous video, we talked about alkanes. Now we're going to move on to the other hydrocarbons. So the IUPAC names for alkenes and alkynes are similar to those for alkanes. We use the same prefixes to indicate the number of carbons in the parent chain. The key difference is we replace the ending ANE, which we use for alkanes. We're going to use ENE for alkenes, and we're going to use YNE for alkynes. And then we're going to assign a number where the double or triple bond occurs. So here's a table showing the simple ones. So 2 carbons would be F. If it's single bonds, it's ethane because it's an alkane. If there's a double bond, it would be ethene. If it's a triple bond, it would be ethyne. Or if you had 3 carbons and they were all single bonds, it would be propane. Or if there's a double bond, it's an alkene, so it's propene. Triple bond with 3 carbons is propyne because it's an alkyne. Now, this last point doesn't really come into play unless you have more than 3 carbons. So let's take a look at these molecules here. So each of these molecules has a number of carbons. So let's number it. 1, 2, 3, 4, 5, 6. And so we know that this is going to be hex because there's 6 carbons. And there's a triple bond, so this will be hexyne. But we want to specify where the triple bond occurs because it could be at the end of the molecule, it could be kind of in the middle, or it can be totally in the middle. And so we put a number where the triple bond starts. So in this case, it starts at carbon number 1. So this would be 1 hexyne. Now the next one here still has 6 carbons, so it's also hexyne. But we can tell that this one's different than the first one. And the way we specify that difference is specifying where the triple bond occurs. And so it starts at carbon 2. So this would be 2 hexyne. The last one here at the bottom also has 6 carbons. So it's also hexyne. But the triple bond starts at carbon 3. So this is 3 hexyne. And so we use the number to specify where the double or triple bond occurs. So 1 hexyne versus 2 versus 3. And you can see these are different structures, and we specify that difference using the number. So quick flow chart for naming these. Pick the longest continuous carbon chain, and that's going to be the parent. You number the chain so that the double or triple bond has the lowest number possible. And then you assign the location for the substituents if there are any. So let's do a practice. Name each of the following molecules. Let's start with this one on the left. So I'm going to number this 1, 2, 3, 4. So that's going to be bute. And we can see that there's a double bond, which means it's an alkene. So this is going to be butene. And it looks like we have a methyl group at carbon number 3. So this would be 3-methyl. And the double bond starts at carbon 1. So this is 3-methyl 1-butene. Now, this one, here's our parent. But we want to number it so that the triple bond has the lowest number possible. So 1, 2, 3, 4, 5, 6. So this will be hex, and because it's a triple bond, it's an alkyne. So this is hexyne. And the triple bond starts at carbon 2. So this is 2 hexyne. And we have a substituent here. This is an ethyl group because it's 2 carbons long, and it's attached at carbon 4. So 4-ethyl 2-hexyne. It looks like we named them right. Now, in the previous video, we learned about cis-trans isomers. And so when we're naming these, we use the prefix cis or trans, and we throw that all the way at the front of the molecule. So let's name these. Now this one has 1, 2, 3, 4, 5, 6 carbons. So it's hex, and there's a double bond, so it's hexene. And we can see that the double bond starts at carbon 2. So this is 2-hexene. And we see that the carbon chains are on opposite sides. So this would be trans 2-hexene. Now, this one on the right also has 6 carbons. So it's also hexene. The ene, because there's a double bond. The double bond starts at carbon 2. So it's 2-hexene. And we see that these carbon chains are coming off the same side. So this is cis 2-hexene. So once again, if you're trans, you put that at the front. If you're cis, you put it at the front. Okay. Let's do a quick study check. Name each of the following molecules. All right, let's start with the top left. We need the longest continuous chain of carbons, which looks like 4. Oops. 2, 3, 4. So that's going to be bute. And there's a double bond, which means it's an alkene. So it's going to be butene. Where does the double bond start? Carbon 2. And it looks like we've got a chloro and another chloro substituent. And so that's dichloro. And the chlorines are attached at carbons 2 and 3. So 2,3-dichloro 2-butene. All right, next one. Number of the parent chain. It looks like this one is also bute. Because it's a double bond, it's an alkene, so we get butene. The double bond starts at carbon number 2, so 2-butene. And then it looks like we've got bromines at carbons 2 and 3. So we've got dibromo, and that's 2,3-dibromo. Now, what I didn't do in either of these is specify cis or trans. So let's not forget that. And it looks like the chlorines are on the same side of the double bond. So that would be cis 2-chloro or cis 2,3-dichloro. And over here, the bromines are on opposite sides. And so that would be trans 2,3-dibromo. Now, this one here on the bottom, let's number it. 1, 2, 3, 4, 5. So that's going to be pent for 5 carbons. Ene, because it's an alkene, has a double bond. The double bond starts at carbon 2. So this is 2-pentene. And we have a methyl group. So this is 2-methyl. But this one is neither cis nor trans, because at the end of this double bond here, those are both CH3s. So those are the same. So it's neither cis nor trans. So there we have it. Cis 2,3-dichlorobutene, trans 2,3-dibromobutene, or 2-methyl-2-pentene. All right, let's take it up a notch. Cycloalkenes. So if you have a cyclic ring with a double bond, it's a cycloalkene. The double bond is always located between carbons 1 and 2. That's by default. We do not include numbers for the double bond because it's always between 1 and 2. The ring is numbered to give the first substituent the lower number. And we don't use cis or trans because any cycloalkene smaller than like 8 carbons, it's always cis. If it was trans, you couldn't like close it into a ring because the bond angles would just be too skewed. So we don't have to specify cis or trans because they're almost always cis. So as an example here, this ring has 5 carbons, so it's pent. We use the ene ending because there's a double bond. The double bond always occurs between carbons 1 and 2. And so we would start number 1 here to give the substituent the lowest number possible. So 1-methyl-cyclopentene. Now this example on the right, we have 6 carbons in the ring. So that's going to be hex, ene, because there's a double bond. Now we want to start number 1 here because that gives our first substituent the lowest number possible. So this is 1, 2, 3, 4, 5, 6 dimethyl cyclohexene. Let's do some practice. Name the following alkenes and alkynes. Well, actually, there are no alkynes, but let's name these. So the first one looks like we have, whoops, double bond is always between carbons 1 and 2. So 6 carbons in the ring, that is hex, ene, and because it's in a ring, cyclo. So cyclohexene, no substituents, so nice and simple. The next one here, we've got 5 carbons in the ring. So cyclo for ring, pent for 5 carbons, ene because there's a double bond. Now when we number this, we can number it 2 ways. We could go 1, 2, 3, 4, 5, or you could number it the other way around. You could do 1, 2, 3, 4, 5. Those are your only 2 options because the double bond has to be between numbers 1 and 2. Now, if we did the blue numbering, this would be 5, 5 dimethyl. Or if we did it in red, it would be 3, 3 dimethyl. We want the lowest number for the substituent, so this is incorrect. So we're going to stick with the red numbering scheme. So number it starting here, so 1, 3. 3, 3 dimethyl cyclopentene and cyclohexene. All right, so that's it for this video. To recap, when you're naming alkanes, you use the ending ane for single bonds. If there's a double bond, we use the ending ene. If there's a triple bond, we use the ending yne. We use a number to specify where the double or triple bond starts in the molecule. And if the double bond is cis or trans, we use cis or trans at the front of the name. Rings are numbered so that the double bond is always between carbons 1 and 2. And we number clockwise versus counterclockwise to give the first substituent the lower number. All right. Thanks for watching, and I will see you in the next video.